This is the second of 4 video clips based on the vector journeys, and it's applicable to National 5 and higher, although some of the higher work may include some angles. Okay, so what we're going for is, this is the second one, and we're going to go for question 3, and we're using the Pegasus questions from Pegasus 2012. Right, let's go for question part A. So in the diagram, M is the midpoint of BC. Okay, express each of the following displacements in terms of vectors P and Q. Now I could see that being something that could be involved in your exam question, so it's a good one to try and understand. So let's go ahead and do that. And remember, what we've got is a midpoint, so we know that BM is the same size as MC. Okay, let's go ahead and work this one out. So I've got CB first of all. So C to B. So C to B, I don't know anything about that yet. So what I could do is I could use an alternative route for this. So I'll go from C to A first of all. And then from there, what I'll do is I'll go from A to B. So that gives me C to B. So I know that vector CA is going in the opposite direction of P. So that's going to be minus P. And for A to B, it's Q. So that'll be plus Q there. Part B, I'm looking for BC. So B to C, okay, so it's just the reverse of CB, so I could just reverse the signs on this one here. That would be a quick way to do it, or I can just think about the journey that I'm going to go. So I'm going to go back the way here, so I'm going to go from B to A, and then go from A to C. So B to A is opposite direction of Q, so that would be minus Q, and it's the correct direction for P, the vector P, so that will be plus P. And as you can see, it's just the opposite of the one just above in part A. B to M next, okay? So if I look at B to M, so B to M is just from there to there. So let's see, could I go that way there? Okay, no, not really, because I don't really know what AM is at the moment. In fact, I'm asked for that next. But what I do know is I know what BC is, because I just worked that out previously. So I know that if that's the midpoint, then B to M is going to be half of BC. So it's going to be equal to a half of B to C. So I already know that B to C is minus Q plus P. And that there would be good enough for my answer. Right, let's look at part D. And what we'll work out is AM next. A to M. So A to M, an alternative route for that, because I don't know about that at the moment, would be going from A to B, which I know, and from B to M, which I've already worked out. So let's do that. So we'll go from A to B, first of all, and then I'm going to go, the journey will be B to M. Right, so A to B is just Q, and what we have is for BM is up above, and I'm just going to take that down, so it's going to be plus a half minus Q plus P. Okay. Right, I'm going to have to tidy this up. What I'm going to do is I'm going to multiply the bracket out first of all. So there's Q plus, let's see, let's go for a half P here, and that'll be minus a half Q. I'll just reverse them round, okay? And gather the Q's together and the P's, so I've got a half P here, and what I've got is I've got plus a half Q, okay? And that would be that. If I wanted to tidy that up or prove it, you know, was something that was given, I would just take a common factor out and give the answer like that there. Okay, so that's the question 3 complete. Let's move on to question 4. Have a look at that. Right, EFGH is a parallelogram, M is a midpoint of the side from H to G. Express each of the following displacements in terms of vectors A and B. Right, let's go ahead and we'll work this out. Okay, so we know that in a parallelogram the opposite sides are parallel and the same size. Opposite sides here also same size, and they're also the same direction. Right, let's go for FG first of all. FG. So F to G, and if I look in a parallelogram, that's the exact same as E to H, so that just equals E to H. And if that equals EH, then from there I can say that EH is just equal to B. So the vectors are exactly the same. Right, so for B, I'll go for GH now. So from G to H in this parallelogram is exactly the same as using the vector from F to E. So that's equals FE. Remember, direction very important in this one. So that vector there from F to E in that direction is equal to the vector A. Per C, we'll go for working out the vector GM in terms of A and B. So G to M, so that's just halfway along that. Remember, it's a midpoint. So I know that that's half GH, which we've just worked out before. So that's going to be equal to a half of GH. GH is just A. So there we go, it's just a half A. For part D, I have to work out the vector FM in terms of A and B. So F to M. So what I could do with that, I could go around this route here and work it out, or I could just go up from F to G and G to M. That's the way I'm going to go. So just using an alternative route. Okay. So FG, and I'm going to add to that G to M. Right, so I think we've already worked out FG, and FG is B because it's the same as this vector across here and in the same direction, so that's going to be B. And over here I've got GM, so G to M is a half A, so really that's my final answer there. Okay, that's the second of 4 videos concluded, and the next ones certainly are a bit more complex than the ones we've done so far.